Given good care, the diesel engine provides a maximum of effect on a minimum of oil consumption. The engineer will see to that. At the moment, he's checking the temperatures of exhaust and cooling water. His routine inspection takes him further down to the second platform with the intercoolers for charging air. Now he reaches the bottom, where his flashlight reveals the return piston cooling oil behind the sight glasses. To make a further study of the diesel engine, we leave the engineer and his instruments and put sight glasses on the engine from top to bottom. This reveals the movable parts: pistons, piston rods, crossheads. And connecting rod and crankshaft. This sectional view shows the function which the most important parts of the engine have to perform. In the upper part of the cylinder, an amount of fuel oil is burnt, which causes the temperature, and thereby the pressure, to rise in the combustion space. The gas pressure acts on the piston, from which the force is transmitted through piston rod and crosshead to the connecting rod, and results in a torque. The thermal energy has been converted into mechanical energy. In an arbitrary piston position during the working stroke, the crosshead is exposed to a vertical force from the piston rod and a force in the direction of the connecting rod, which together result in a horizontal force. This horizontal force must be transmitted to the engine frame, and for this purpose the crosshead is provided with slide shoes supported on vertical surfaces, the guide faces on the engine frame. Powerful forces are at work in a big marine engine, and accordingly the engine parts are of big dimensions. In the workshop, with people providing a natural yardstick, one receives a good impression of their size. So big must the crosshead slide shoes be in order to transmit the horizontal forces. The high points in the connecting rod bearing, which have been spotted by the contact with the crosshead pin, are scraped off in thin chips. To provide tightness against the high pressures, the piston is fitted with piston rings. The ring is fitted by a special tool which imparts an evenly distributed bending moment to it, thus preventing the danger of a permanent deformation. The cylinders are not easily overlooked either. The scavenge air ports are bored oblique to a diametral plane to set the scavenge air in rotation. crankshaft is so big that to facilitate manufacture and installation, it's made in two halves, which are bolted together later. Each half is built up from a number of individual parts. Main bearing journals, crank webs, and crank pins. The crank webs are provided with counterweights. Let's look a little closer at the principle on which a two-stroke engine works. Fresh air is supplied by a blower. From the blower, it's conducted in a pipe along the engine to the scavenge airspace around the cylinder. When the piston approaches the end of the downstroke, the exhaust valve opens, the scavenge air ports are uncovered, and fresh air flows up through the cylinder. Exhaust valve and scavenge air ports are then closed, and during compression, the air is heated for ignition of the injected fuel. The combustion increases the temperature and thereby the pressure which drives the piston. The exhaust valve opens, the pressure falls, and the combustion products are expelled. The air is again compressed. Fuel is injected, ignited. The gases expand. The exhaust valve opens, then the scavenge air ports. The cylinder is scavenged, and the cycle is repeated. The power developed by an engine depends on the pressure events in the cylinder. Before the engine is started, cooling water and oil are turned on. Also, compressed air is needed for the starting. The control lever is moved, regulating the fuel pumps for increased injection. The speed of revolution is rising. The engine has now reached its full RPM, and we are able to find the power by means of the torque registered here on the dynamometer. If at the same time we measure the consumption, the air and cooling water quantities, and the temperatures, a heat balance can be drawn up. The engineer is still on his job, securing a long life for his engine by checking and testing. And one thing more, by knowing the meaning and function of every little detail of his engine.